Alright, this is Math Week 5, Activity number 3, and we are looking at Lesson 18.8, Metric Units for Mass, starting on page 607 through 609. Okay, let's look at page 607, Metric Units for Mass. Peter has a dollar bill in his pocket. Should Peter measure the mass of the dollar bill in grams or kilograms? The gram is the basic metric unit of measure for measuring mass, or the amount of matter in an object. Mass can also be measured by using the metric unit kilogram. So a small paper clip has a mass of about 1 gram. Okay, so if you've ever held a paper clip, not very heavy. If you're relating it to our last lesson when we talked about ounces and pounds, then grams and ounces would be closer to each other in weight. They're the lighter unit that we're going to use today. A box of 1,000 paper clips has a mass of about 1 kilogram. So that's an important thing to remember today, that it takes 1,000 grams to equal 1 kilogram, and we abbreviate that kg, kilogram. So back to Peter and his dollar bill. The mass of the dollar bill is closer to the mass of a small paper clip than it is to the box of 1,000 paper clips. If we held a dollar bill and a paper clip, they would be closer in heaviness than the 1,000 paper clip box, which is pretty heavy. So Peter should measure the mass of the dollar bill in grams. Now in this first activity, this is something we would normally in class probably even be using the page from the book. We would maybe have stations set up and have out our pan balance to measure, but since we've got to work with what we have, we're going to have to just kind of pretend today. Maybe though in science this year you have gotten to use the pan balance is to find the mass of some different things. So hopefully you've had some experience with this. And what we do is we put things on either side, and we try to balance them up. Like if I put an object on one side, and then we use little gram weights or kilogram weights until the two sides are balanced. And then we'll know how many grams it took to weigh the same as whatever item I put on the other side. If it was 10 grams or 20 grams, we could kind of see that by looking at the balance. Okay, so it says, do 10 grams have the same mass as 1 kilogram? So we would take our pan balance and we would put a kilogram weight on one side and 10 gram masses on the other side, and we would see if they balanced. So since we don't have them here, we're going to have to kind of use our brains a little bit and our common sense a little bit to think about what we learned up here at the top. We learned that 1,000 grams equals 1 kilogram. So would 10 grams balance with the 1 kilogram? Well, the answer to that is no, because it takes 1,000 grams to balance or equal the 1 kilogram. So if we were putting the two masses on here, the kilogram and 10 grams on here, then the one that would be heavier, the one that would be down on this side, would be the kilogram. So I'm going to draw a big weight. They're actually kind of, our kilogram weights look something like this. 1 kilogram. And then we have these little flat discs for the grams, so we'll pretend these are them. I'm going to draw 10 of them. 2, 3, 4, 5, 6, 8, 9, 10. I'm just going to put a G, because in our classroom set they are labeled with a G on each one. But even though on this picture it looks like that would be more, they're not as much as the 1 kilogram weight. So we completed the picture. The pan balance is unbalanced. They want us to note right there. So 10 grams and 1 kilogram don't have, I can't fit that in there, don't have the same mass. Okay. All right, let's turn the page. On page 608, we have another activity. This would be something we would do in our table groups and things with our pan balance, but instead I just had to do a little bit of internet research to figure these out because I don't have a pan balance at home either. But we are going to look at these 4 objects, and we're going to decide if we were measuring them in class, would we be using the gram weights to balance, or would I use kilograms? So we would only use kilograms if it weighed at least a kilogram. And another, I'm going to make a few notes over here you might want to keep in mind. First of all, 1,000 grams equals 1 kilogram. We had that on the other page. But also, I looked this up, that 1 kilogram, wanted to relate it to pounds because we're more familiar with pounds. Remember that in our last lesson, that was the loaf of bread. So a kilogram is actually about, a little bit more, but it's about 2 pounds. It's slightly over 2 pounds. So it kind of gives you just another idea of how much that would feel like. So it's a little bit heavier, a kilogram is, about 2 pounds. So if we had a crown, a single crown, and like the kind you color with, and we were deciding grams or kilograms, well, I don't think a crown weighs 2 pounds or more. So we would weigh it in grams. And in class we would get out the balance and figure it out. But I just looked it up. Online it says that a crayon weighs about 30 grams. Okay, and a stapler. Now, we have different kinds of staplers, but like the metal stapler, like the kind I have in my classroom, it's a bit heavier, but it's not as much as a kilogram actually. And I wasn't sure because it's pretty close. That would be one of those you might have to, in real life, we would have maybe experimented with to see if it weighed as much as the kilogram. But we're going to use grams because when I looked up the mass of a metal stapler, it was 500 grams. Okay, and so that means that it's half of a kilogram. So it's not as much as 1 kilogram because 500 is half of 1,000. So it's not as much as 1 kilogram. Okay, a marker. A marker's pretty light, so of course that's going to be grams. And the mass of a marker, according to the internet, is about 10 grams. And a pair of scissors, and of course it would matter if you were looking at, a pair of small student scissors or like my big pair of scissors that I keep on my desk. But a pair of student scissors, online I said you'd use grams because they would weigh about 40 grams. So we're going to write them in order from greatest mass to least mass. So the greatest is the stapler. And the next largest is the, scissors. Then the crayon. And then the lightest one on this list is the marker. But keep in mind with these things, it's not always the size of the unit. Because some things are more dense and heavier, and some can be larger but still be lighter. So look at our picture of our pan balance here, and we have 5 bananas, and notice the two sides of the scale are balanced. So the 5 bananas have a mass of about 1 kilogram. Now we're going to choose the unit to measure, gram or kilogram. Strawberry is pretty light, so we would use grams. Dog is pretty heavy, so we would use kilograms. And the sunglasses would be pretty light, so we would use grams. Okay, I'm going to go on over to page 609. We have some sports balls over here. We have a golf ball, a bowling ball, table tennis or a ping pong ball, baseball, and a tennis ball. Okay. So we're going to have to imagine, it would be good if we actually had these here, but we just have to imagine, and they want us to put them in order from the greatest mass to the least. So in other words, heaviest to the lightest. So the one that would be the heaviest here, of course, would be the bowling ball. And then we've got golf ball, ping pong, baseball, tennis ball. Baseballs have a little bit more weight to them, so I think the baseball would be next. And then tennis ball, golf ball, table tennis ball. Now, even though the tennis ball is larger, the golf ball would actually have more mass to it, because if you've ever held the two, you know that tennis balls are pretty light. So golf ball would be next. And then the tennis ball. And the lightest one is the table tennis ball. Okay, question 6. One golf ball has a mass of about 46 grams. Mrs. Downs bought a box of 2 golf balls for her first round of golf and bought another box of 2 golf balls for the second round of golf. What is the total mass of the golf balls that Mrs. Downs bought? Represent your steps to solve the problem. Well, first of all, we have 2 golf balls plus 2 more golf balls equals 4 golf balls. And each golf ball equals 46 grams. So I can solve this 2 ways. I could use repeated addition, 46 grams plus 46 grams plus 46 grams, or I can use multiplication, 46 grams times 4 golf balls, 4 times 6, 6, 12, 18, 24, 4 times 4, 4, 8, 12, 16, 17, 18. Hope you're still studying your multiplication facts. So it's 184 grams, or you could have done repeated addition if that's what you prefer. 46, 46, 46 plus 46. 6, 12, 18, 24, 4, 8, 12, 16, 17, 18. Either way, we get 184 grams for her 4 golf balls. Question 7. Our dog Dexter weighs 72 kilograms. He is 8 times heavier than our cat. What does our cat weigh? Alright, so I'm going to turn this into a little equation here. Dexter, the dog, weighs 72. Equals 72 kilograms. which is 8 times the cat, which is equal to 8 times the cat, C for the cat. So we want to know 8 times what equals 72. I hope you still remember your multiplication. 8, 16, 24, 32, and 40, 48, and 56, 64, and 72. So that's 9. The cat equals, wrote it wrong, 9 kilograms. Number 8. Choose 2 objects that have different masses. Draw a balance with one of these objects on each side. So I'm going to draw balance, kind of like what we have here, but it said have them different masses, so I'm going to make sure that one is heavier than the other. And let me think, my 2 objects can be, a pencil. It's one of the few things I can draw. A pencil will be the lighter mass if I compared it to the mass of, let's say, how about my laptop? I can't think of anything. My computer would definitely have a higher mass. And I'm not a very good drawer, so I'm just going to put computer, pencil. Now you can choose your own items and have one be lighter than the other. And our last question for today, Amber is buying produce at the grocery store. She says that a Fuji apple and a green bell pepper would have the same mass because they are the same size. Does her statement make sense? Well, the answer to that is no, because the apple would have more mass. Think about if you cut open an apple, how it's solid inside, and if you cut open a green bell pepper, it's mostly empty on the inside, and so it's lighter. And that's kind of like thinking of these examples of these balls up here, or even if we'd had, say we'd had a beach ball, that would have been a good one to have up here. A beach ball would have been bigger than all of those, but it would have been lighter than, say, the bowling ball. So just because something is larger in size does not mean it has a bigger mass.